This video covers required practical 3, which asks you to identify what is produced during the electrolysis of 4 different electrolytes. We'll cover the method for this practical, a summary of the method which you could use to answer an exam question on this topic, and look at some example results and how we would analyse them. You would set up this practical by setting up the power pack, leads with crocodile clips attached to the power pack at one end and to an electrode at the other end. The first step is to pour approximately 50 centimetres cubed of one of the electrolyte solutions into the beaker. You would then add the Petri dish lid and insert the carbon electrodes through the holes, making sure that they don't touch each other. You would select 4 volts on the power supply and switch it on. Next, you would record your observations for what is happening at each electrode, making sure you know which would be the positive anode and which would be the negative cathode. You would then lift the lid off temporarily so you could hold a piece of damp blue litmus paper over the solution next to the anode and record what you observe happening to the litmus paper. You would then rinse the electrodes with water, and you would then repeat all of the steps until you've tested all 4 electrolytes. Typically, you would use copper 2 chloride, copper 2 sulfate, sodium chloride, and sodium sulfate. We'll now look at a summary of the method which you could use to answer an exam question on this. The first step is to pour one of the electrolytes into a beaker. Then you would add a lid and insert the electrodes, making sure they don't touch. Next, you would turn on the power supply. Then you would record your observations at each electrode. You would lift off the lid and hold damp litmus paper next to the anode and record your observations. You would then rinse the electrodes with water. And finally, you'd repeat all of the above steps with the 3 remaining electrolyte solutions. We'll now look at some example results you might collect during the practical. With copper 2 chloride at the anode, you'd observe bubbles or fizzing. And when the litmus paper was held over this, it would turn white. At the cathode, you would see copper metal being formed. For copper 2 sulfate, at the anode, again, you'd see bubbles and fizzing. And there would be no change to the litmus paper when it's held over. At the cathode, you would see copper metal being formed. For sodium chloride, at the anode, you would see bubbles and fizzing. When damp litmus paper was held over it, it would turn white. And at the cathode, you would also see bubbles and fizzing. For sodium sulfate, you'd see bubbles or fizzing at the anode, and no change to the damp litmus paper when it's held over. At the cathode, you'd see bubbles and fizzing. We'll now use the observations to determine, with a reason, what element was formed at each electrode. We will use the rules for aqueous solutions in electrolysis to figure this out. You may need to recap that topic prior to doing the practical to help you determine what was formed. For copper 2 chloride, at the anode, chlorine gas was produced. This is because chlorine is in group 7, and when we have a group 7 element in electrolysis, we produce that element. The damp litmus paper was also bleached white, which is the positive result for a test for chlorine gas. At the cathode, we saw copper metal being produced. And this is because copper is less reactive than hydrogen, and we always make the least reactive when we compare the metal with hydrogen. So if copper was the least reactive, we would make copper. For copper 2 sulfate, at the anode we produced oxygen gas. This is because sulfate is not a group 7 element, so oxygen and water are produced to the electrode at that case instead. For the cathode, we again saw copper metal being produced. And as before, this is because copper is less reactive than hydrogen. We make the least reactive, therefore we would make copper. For sodium chloride, at the anode we would produce chlorine gas. This is because chlorine is in group 7, and if we have a group 7 element present, we will produce it. And the litmus paper went bleached white, which we know is the positive result for chlorine. At the cathode, we will produce hydrogen gas. And this is because sodium is more reactive than hydrogen. We make the least reactive, therefore we would produce hydrogen. At the anode for sodium sulfate, we would produce oxygen gas. And that is because sulfate is not a group 7 element, therefore we produce oxygen and water instead. At the cathode, we would produce hydrogen gas. And this is because sodium is more reactive than hydrogen. We make the least reactive, therefore we would produce hydrogen.